Alright, moving right along to section 8.8, factor difference of squares. This is going to be a continuation of factoring quadratics. We've already learned how to factor ax squared plus bx plus c with the leading coefficient a as a 1 or with the leading coefficient a as bigger than 1. Now we're going to look at some special polynomials and kind of some things that we can memorize. So first is the difference of squares. A difference of squares is a binomial. That means there's two terms in the form of a squared minus b squared. So you have some number at the front, which is a perfect square, and some number at the back, which is a perfect square. And we can factor it by using the sum times, or product of a sum and a difference formula. So this is the exact formula that we already had when we were learning about distribution, just in the reverse order. So we learned that when you multiply a sum times a difference, you get this shortcut answer out, because the cross terms, the BA and the negative AB, those two cancel out. So if you see something of this form, you can automatically know, oh, that's got to be a sum times a difference. So how can you recognize it? Well, it's always going to be a minus sign, and the two numbers here and here, the two expressions I should say, here and here, are going to be perfect square numbers. Okay, are going to have perfect square numbers in them. So you really need to memorize the list of perfect square numbers, at least the basic most common ones. So of course, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, all the way up to 100. Actually, 11 squared is 121, 12 squared, you probably know it, is 144, 13 squared is 169, and you can just keep going and going and going and going. The more of these you've memorized and the more you can recognize them, the better you'll be at factoring. Okay? So problem solving first, always check if you can do a greatest common factor. Now, even if it's a binomial, there might be something that both terms have in common, and if you factor out the greatest common factor first, that might be all you have to do, or at minimum it will make the problem much, much easier. Okay, so always factor out the greatest common factor if at all possible. That will make your life much simpler. And then, like I said before, memorize and look for those perfect squares. A couple of examples and we'll be done with this quick video. Factor each polynomial. If it's prime, which means you can't use integer factors, then don't do it. So this is a perfect square. We've got a times a, and this is a perfect square. We've got 2 times 2, and the rule is that one is positive and the other is negative. That way the middle terms completely cancel out. Let's look at this one here. The first one and the second one again are both perfect squares. 1 times 1. Square root of 49 is 7. So 7d, because it's d squared here, right? So 7d and 7d, and then obviously one is positive, one is negative, so that the cross terms, again, will cancel out. Okay, we can do this one now. The order here is switched, but you could think of it if you want as p squared minus 16. That's the same thing, right? So in terms of factoring, we get the same thing. In the front, we've got p and p. In the back, what multiplies to 16 is obviously 4 times 4, 1 positive, 1 negative. Okay, let's go down to these. These actually say solve. Okay, now remember, anytime you have an equation equal to 0, if you factor it first, you can use the zero product property. So let's take this one for example. If we factor it first, square root of 16x squared is 4x times 4x. Square root of 9 is 3 times 3, and then 1 is positive, 1 is negative, and that equals 0. Now each of these two guys can be solved, so we can do 4x plus 3 equals 0, and then here 4x minus 3 equals 0. Now to solve this, we want to subtract 3 on both sides, those cancel, then divide by 4, so x equals negative 3/4. And if we do the same steps here, add 3, divide by 4, we get x equals positive 3/4. Okay, so 2 solutions because it's a quadratic. I'm not sure if I've mentioned this in a previous video, but it's a good thing to memorize or to know. The number of solutions to any equation are going to be equal to the highest power of that variable. So if you have an equation with x squared, you'll get 2 solutions. If you have an equation with x cubed, you can get 3 solutions, etc., etc. Let's do our final example here. Let's try number 18. Again, this is a perfect square, so the square root of 81 is 9, so we got a 9 and a 9. The square root of 4b squared, square root of 4 is just 2, and square root of b squared is b. So a 9 and a 2b. 1 is positive, 1 is negative, and that equals 0. So by zero product property, here we set this piece equal to 0, so 9 plus 2b equals 0. So what's b going to equal? Well, we subtract 9 and then we divide by 2. So subtract 9, divide by 2, we get 9/2. And you notice a pattern here, they're always the same, they just have opposite signs. So the other answer is b is going to be positive 9/2, right? Cool. You might have thought to yourself, if I wanted to solve this equation, a totally unrelated little method here, which we're going to cover later, but I'll mention since it's here. Why don't I just add 4b to both sides? So if I have 81 equals 4b, 81 minus 4b squared equals 0, I could add 4b squared on both sides, and then I would get 81 equals 4b squared. Then I could divide both sides by 4, and I'd get 81 over 4 equals b squared. And then the opposite of squaring something is taking the square root, and the square root of 81 is 9, square root of 4 is 2, and then you get plus or minus. So this kind of method, I just give you a little preview there. You don't have to write this one down if you don't want to, but a little preview of what's coming at the end of this chapter is solving equations by working backwards and taking the square root. So it's kind of cool. It's very similar to absolute values, and we'll get there soon enough. For now, though, enjoy the shortened video, and I'll see you in class.